Let us see how we can deploy a web application on Google Kubernetes engine. Hi, myself Anjana Sebastian. I'm a full stack developer based in Singapore and currently associated with Syntech A-Star. I love to code to solve real world problems, and also I have interest in Google Cloud technologies. During these COVID times, we have seen large and fluctuating volume of data orders coming into retail applications. Can we handle these kind of fluctuating orders only using a monolithic application and physical servers? So I thought of a cost effective solution and I was trying to see how we can make use of Google Kubernetes engine. So here the agenda is first we need to have a sample project and we are going to access that project from the Google Cloud Shell. Then we are going to build the Docker image from the sample project. Then we are going to push that Docker image to the Google Container Registry. Then we have to create a Google Kubernetes Engine cluster and deploy our application on the Google Kubernetes cluster. And then we can access the application on the web browser. So the components used in this application from the Google Cloud Platform, I have made use of Google Container Registry, which is highly available and reliable to store the container images. And Google Kubernetes Engine allows us to create clusters in single click, which can be scaled up to 15,000 nodes. So for the project, I have made use of Angular for the front end, and for the API side, I'm making use of Node.js Express API, and for creating the images, I'm making use of Docker, and for the container orchestration using the Kubernetes. So, what are the benefits of containerization? Portability. We can abstract away the application from the underlying OS and it can be deployed on any system, any server or cloud. And these applications can be scaled up based on the load. And these applications are lightweight and can be deployed very fast. And using these container or containerization technologies, we can manage these applications very easily. And these containers developed are deployed independently. So the failure of one container will not affect the other applications, and hence the business continuity is always maintained. Yeah, the security is improved because in each container level, it is in isolated, and the productivity, all these because of all these facilities, the productivity from the developers has increased. Now let us see a standard cluster architecture for a Google Kubernetes engine, which will be running on a zonal container. So for a zonal cluster, there will be a single control plane, and there are going to be a set of nodes, node pools. Node pools will be having identical virtual machines, and inside the node, what is a node composed of? A node is going to have a set of ports, and these ports are the smallest deployable unit, and each port can have one or more containers running on it. And a group of pods are creating the node, and they are worker machines. They can be physical machines or virtual machines. And also we can see like we need to have services. So these services will allow us to access our ports, access our applications running on the ports through the network. And this cluster is also connected to other Google Cloud services like VPC networking and container registry, load balancer, and also like stack driver for monitoring and logging purposes. So for starting with our migration of our project, first we need to have a sample GCP account. We can create, it's very easy. And once we create the project, we have to make note of the project name and the project ID. Then we have to associate our project to the billing account. Next, in this throughout this presentation, I will be either making use of Google Cloud Shell or the Google Cloud Console. So from the Cloud Shell, we can clone our project. So the source repository looks like this, and it has my app folder where we have the basic Angular application, and we have a Docker file for the Dockerization, and we have a manifest file for the deployment, and we have our server.js file which has the Node.js Express web REST APIs. So we have our project. Then we can navigate inside the project folder. Then we can configure the Docker on the Google Cloud Shell to make use of Docker. Once then we can create our image, as in we can build our image using Docker build command. So once we build the Angular node image, we can tag our image. When we are tagging the image, we have to make use of our project name, and also I am here tagging it as Angular web app with version v1. Once we have our image ready, we can push our image to the Google Container Registry. It is highly secure and highly available, and they have vulnerability scanning for the images. All these things will be taken care by Google. So first we have to enable the Google Container Registry. So to enable the container registry, we can use the following command: gcloud services enable container registry.googleapis.com. So once the container registry is enabled, we can push the image we have created into the registry using docker push command. After the image is pushed successfully, we can refresh the container registry, and we can see that our Angular web app image is already uploaded. So now we have the image ready on Google Cloud. We have to create Google Kubernetes engine cluster. So what is a Google Kubernetes engine? It is a fully managed Kubernetes service on GCP. It is highly reliable, efficient, and to, to run our clusters, and auto scaling. It supports auto scaling, auto upgrade, and auto repair. And we can create clusters on zone and also on regional level. It is integrated with other Google Cloud technologies also. So let us see how we can create a Google Kubernetes engine cluster. First, there are two modes of operation. First one is the standard mode, where the user will have the flexibility to do the setups. And another one, the fully managed solution, is the autopilot mode. Here I am choosing the standard mode, and then we can name our cluster. Then we can decide uh, whether we want a zonal cluster or a regional cluster. So in this case, I'm choosing a cluster which is near to Singapore. Then I'm going to create the cluster. Yeah, now the cluster is ready. So we have so many operations we can perform on this cluster. We can add more node balls, and we can deploy applications on our cluster. We can duplicate and create a similar cluster, and also we can connect to the cluster. And here we can see our node details. Here I have selected 3 nodes, and also we can see the node details and the system details. Now I am going to connect to the cluster so that we can deploy our application here. So for deployment, first we are going to connect to GKE cluster, and using our project ID and the zone, we get the credentials, and we are connecting to the cluster. So once we successfully connect to the cluster, we have to deploy our application. So for that, we have to first update our manifest file. So in the manifest file, in the image tag, we have to update it with the image we have uploaded to the Google Container Registry. Then we can specify the number of replicas. In this case, we are trying to see how we can handle fluctuating loads or large volume of load. So I am trying to create 5 replicas of the application. So once we create 5 replicas, we need to set up a load balancer service. And this load balancer service, we can specify on which port we are going to make it available to the web browser. So in this case, we can specify the port, and also we have to specify the service. So with all that, we can create the deployment object. So once we make all changes to our manifest file, we save our file, then we can create our manifest file, kubectl create -f manifest.yml. So once we create, we can verify what happened to our deployment. So kubectl get deploy command will help us to see what happened to our deployment. Then we can see the ports details using kubectl get port command. Then to access and to see the details of our service, we can use kubectl get service command. So let us see here on kubectl get deploy, we can see our application is up, and we have 5 replicas created. And with the kubectl get service command, we can see the cluster details, and we can see the external IP address and the port where the application is exposed to. So using this IP address and port, we can access our application from the web browser. Yeah, here with that same external IP address and port, I was able to access my application. I was able to create orders, and I was able to view orders. So we were able to create scalable solution using GCP, and we were able to access the application running on the web browser. And this has improved the user experience by providing highly available, reliable, and a scalable solution. And throughout this, we were fully focused on the development rather than the infrastructure management. So, what are the next steps? So, we have a web application. So, we can extend this application to make a full stack solution utilizing technologies like Cloud SQL, which is a fully managed service for data storage. I have added all the screenshots in the following appendix slides. Thank you.